In this lesson, we're going to look at the opposite of squaring and cubing. In this first part, we're going to look at the opposite of squaring. Now, the opposite of squaring something is the inverse operation, which quite a lot of maths calculations have. The opposite of add, for example, is take away. The opposite of multiply is divide, and so on. The opposite of squaring is, in fact, square rooting. So it's the reverse process. 8 squared is 64. 8 times 8 is 64. What we're really asking is, what number do you multiply itself to get 64? You're starting with the answer, if you like. That's called the square root of 64. So the square root of 64 is 8, written like this. Now, you can get exact values for quite a lot of square roots, in fact all the square numbers. So 64, the square root of 64 is 8, the square root of 81 is 9, because 9 times 9 is 81. The square root of 100 is 10, because 10 times 10 is 100. Some square roots are not exact, however. Sometimes when you square a number that's not a square number, you'll end up with a decimal. These here are called surds, but we'll investigate that later. The other thing we've found is 4 cubed is equal to 4 times 4 times 4, which is 64. The reverse of this process is called cube rooting. You're starting with the answer and trying to get back to what to the power of 3 equals 64. Or another way to look at it, which number times itself 3 times equals 64. So we know this is 4. So that's called the cube root. The cube root of 64 is 4. Or we write it like this, a wee square root sign and a wee 3 to signify the cube root of 64. There's a lot of cube roots as well. Cube root of 27 is 3. 3 times 3 times 3 makes 27. The cube root of 125 is 5, and so on. Some of them you'll get to memorise. And also some cube roots do not give a whole number as an answer. For example, cube root of 7 is 1.9129. Right, let's look at some examples. So, the first example, this is questions asking for the square root of 36. Now, because I know 6 times 6 makes 36, I know this answer is 6, because 6 squared is 36. This question is saying, what is the fourth root of 81? So what times what times what times what? Something multiplied by itself 4 times makes 81. Now that's 3. Because 3 to the power 4 is 81. 3 times 3 is 9, times 3 is 27, 27 times 3 is 81. What is the fifth root of 100,000? So what multiplied by itself 5 times makes this? That's 10, because 10 to the power 5 is 100,000. If you're square rooting a fraction, the way to do this is to square root the top number and also square root the bottom number. So that's equivalent to square root of 16, which is 4, and square root 81, which is 9. Another way to look at it is 4 over 9 squared is equal to 16 over 81. 4 times 4 and 9 times 9. And the cube root of 8 over 27, just do a cube root of 8. Now 2 times 2 times 2 is 8, so that's 2. And 3 times 3 times 3 is 27, so that's 3. Again, you could say that 2 over 3 cubed equals 8 over 27. 2 times 2 times 2 gives you the 8, and 3 times 3 times 3 gives you the 27. Okay, let's look at these last 3 examples. So what we have to do here is work out the square root of 16 cubed. Now, do the inside of the bracket first, and then cube your answer. So, square root of 16 is 4. So really what you're doing there is you're doing 4 to the power 3. That's 4 times 4 times 4. 4 4s are 16, times 4 is 64. You can write a summary if you need to do that. Okay, and the second one here, do that first, do inside the bracket first. So the fourth root of 81 is 3, so 3 squared, 3 times 3 is 9. And lastly, do the bracket part first. So 6 times 6 is 36, and 8 times 8 is 64. So you're really doing the square root of 36 plus 64. Again, do your brackets next. So that comes to 100, so you're square rooting 100. And then what times what makes 100?